Have you ever looked up at an airplane and wondered, how does that massive thing stay in the air? It seems almost magical, doesn't it? We're used to things falling down, not soaring above the clouds. But here's the secret. Flying isn't magic, it's science. By understanding a few basic principles, we can unravel the mystery of flight. The science behind flight is all about forces, invisible pushes and pulls that act on objects. When an airplane flies, it's like a beautifully choreographed dance between these forces. Get the balance right and you're soaring through the sky. Get it wrong and, well, let's just say it's important to get it right. Before we dive into the forces, let's get to know the star of the show, the airplane itself. This incredible machine is a marvel of modern engineering, designed to conquer the skies and transport us across vast distances. Just like a bird has wings, a body, and a tail, so does an airplane. These components are essential for flight, each serving a unique and vital purpose. Each part plays a crucial role in getting and keeping that plane in the air. From takeoff to landing, every element must work in harmony to ensure a safe and efficient journey. The wings are the most obvious part. They are the primary lift-generating surfaces, allowing the plane to rise off the ground and stay aloft. They're specially shaped to generate lift, the force that counters gravity. The curvature and angle of the wings are meticulously designed to maximize this effect. The engines, whether jet engines or propellers, provide the thrust needed to move the plane forward through the air. This forward motion is crucial for maintaining lift and achieving flight. The cockpit is where the pilots sit, like the brain of the bird, controlling the plane's movements. Here, pilots manage all the systems and navigate the skies with precision. Finally, the tail helps stabilize the plane and control its direction. It ensures the aircraft remains balanced and can maneuver effectively during flight. Now let's talk about those invisible forces that make flight possible. There are four main ones: lift, thrust, drag, and weight. Lift is the upward force that opposes the plane's weight. Thrust is the forward force generated by the engines, propelling the plane through the air. Drag is the resistance the plane encounters from the air itself. It acts in the opposite direction of thrust, like an invisible hand trying to slow the plane down. And finally, weight is the force of gravity pulling the plane down towards the earth. It's the force that lift needs to overcome to get and keep the plane in the air. Section 4, the science of Lift-Bernoulli's principle. We know lift is crucial for flight, but how does it work? How does a massive metal object like an airplane manage to soar through the skies with such grace and power? This is where things get really interesting. The science behind it is both fascinating and complex. The shape of an airplane wing is the key. It's not just a random design, it's meticulously crafted for a specific purpose. It's curved on the top and flatter on the bottom, a shape called an airfoil. This unique design is essential for creating lift. This shape is designed to manipulate the flow of air over the wing. The airfoil's curvature and angle play a crucial role in how air moves around it. As the plane moves forward, the air splits and flows over and under the wing. This movement of air is fundamental to generating lift. Because of the wing's shape, the air traveling over the top has to travel a longer distance in the same amount of time. This difference in distance causes a difference in speed. This faster moving air creates lower pressure above the wing, while the slower moving air below creates higher pressure. This pressure difference is crucial. This difference in air pressure is what generates lift. The higher pressure underneath the wing pushes up more forcefully than the lower pressure above the wing pushes down. The higher pressure underneath the wing pushes up harder than the lower pressure above the wing pushes down. This creates an upward force. This upward force, lift, is strong enough to overcome the weight of the plane and lift it into the air. It's a perfect balance of forces that allows airplanes to take flight and stay aloft. Section 5, working together, achieving flight. So how do all these forces work together to make an airplane fly? It's a fascinating dance of physics and engineering. Imagine this. The plane's engines generate thrust, propelling it forward. This thrust is crucial as it sets everything in motion. As the plane moves faster, air flows over the wings, creating lift. Lift is what allows the plane to rise into the sky. Once the lift force becomes stronger than the force of gravity, the plane's weight, the plane takes off. This moment is a triumph of engineering. Of course, drag is always present, trying to slow the plane down. Drag is the resistance the plane faces as it moves through the air, but as long as the engines provide enough thrust to overcome drag, the plane will continue to move forward and stay airborne. This balance is key to sustained flight. It's a delicate balance of forces, a constant interplay between lift, thrust, drag, and weight. Each force plays a vital role in the journey. And there you have it, the magic of flight, demystified. It's a beautiful symphony of science and technology. It's not magic after all, but the elegant application of scientific principles. Pilots and engineers work together to harness these forces. Next time you see an airplane soaring through the sky, remember the invisible forces at work and marvel at the ingenuity of human invention that makes it all possible. It's a testament to human curiosity and our desire to explore the skies.